To look at probability for Module 2 in Sims 2, we need to be familiar with our vocabulary. First we have an allele. Each of the letters in a genotype is called an allele. Genotypes come in three forms: 2 capital alleles, 2 lowercase alleles, or 1 uppercase and 1 lowercase. Be aware that a lowercase followed by an uppercase is the same as an uppercase followed by a lowercase. I'm referring to this genotype here. If you reverse the letters, it's really the same genotype. Phenotypes are what you see. For example, the dominant trait, capital F, having free earlobes, or the recessive trait, lowercase f, having attached earlobes. Dominant traits are always written as a capital letter, and dominant traits always mask the recessive. So for instance, these two genotypes would both be dominant, they would both be free earlobes. This genotype, made up of 2 recessive genes, is the only genotype that gives the phenotype for attached earlobes. Recessive alleles are always written as lowercase letters. Let's look at a Punnett square, doing a cross of capital R with lowercase r. So what we do is we write one of our genotypes to the side, one of our genotypes up above. As you can see, this capital R moves in to the right, this capital R moves in to the right. This lowercase r drops straight down, this lowercase r drops straight down, and it turns out we get all 4 of our resulting genotypes to be identical. In our textbook, capital R represents the ability to roll your tongue, lowercase r represents the ability to not roll your tongue. When we look at the genotypes, there are 3 possible probabilities. The probability of getting 2 capital alleles, the probability of getting 1 capital and 1 lowercase allele, and the probability of getting 2 lowercase alleles. Remember, 3 different genotypes are possible. Were there any capital R results? No. So the probability for getting that is 0. How many capital R, little r results were there? Oh, all 4 out of 4. 4 out of 4 is a probability of 1. And were there any lowercase r's resulting? No, there were not. So the probability was 0. So again, for genotypes, there will always be 3 probabilities you can look for. 2 capital, 2 lowercase, 1 of each. For phenotypes, there are only 2 possibilities: the dominant trait and the recessive trait. The dominant trait, again, is the ability to roll the tongue. So I look at my result in my Punnett square, and I look for dominant alleles. All 4 out of 4 have dominance. Therefore, 4 out of every 4 children, or 100%, or 1, can roll their tongue. None in this particular cross would not be able to roll their tongue. Let's look at another cross. Let's do the cross of capital A with little a. So again, I put one set of my genotypes on one side, the other set of genotypes on the top. Notice, straight in, straight down. Now this time I ended up with different genotypes. For this instance, I'm using capital A to represent having a widow's peak in your hair, and a lowercase a to not have a widow's peak in your hair. How many genotypes are possible? That's right, there's 3. 2 capital A's, 2 lowercase a's, and 1 of each. How many double capital A's did we end up with? Oh, none. So what's the probability of getting that? 0. How many uppercase A, lowercase a combinations did we get? Oh, look, 2 out of 4. 2 out of 4 reduces to 1/2. And double lowercase. Again, 2 out of 4, which reduces to 1/2. So the probabilities for my genotypes are as follows. How many different phenotypes are possible? Always just two. The dominant trait and the recessive trait. Remember, to get the dominant trait of widow's peak, I just have to have a capital A, whether it's double capital or capital lowercase. Come back to my resulting Punnett square. Half of my Punnett square has capital A's. The other half has all lowercase. For this phenotype, it's split 50-50. 50% of these kids would have widow's peak. 50% of these kids would not have a widow's peak.